we started off already talking about a pedigree. What a pedigree is, that is fine. But on your note sheet, we want to go ahead and take some information and take a look at some things. So, what is a pedigree? Who remembers what a pedigree may show? Talk with your group for just a second, about 30 seconds, to discuss what a pedigree shows. We didn't do a whole lot with it on Friday, but we did some. All right, Drika, what'd your group talk about a pedigree showing?
We said it shows a connection.
A connection, we also call that a what? Relationship or a connection. So it shows a relationship within a family. A pedigree is much more than a relationship, however, because it's going to help to chart how one gene passes from generation to generation. So it's going to show a relationship between family members, how genes can be passed from generation to generation. First part is just a family tree, the relationship, correct? Would you agree?
Correct.
The second part now gets into genetics, what we've been discussing. We need a Punnett Square. We need to look at that information. But to go a little bit deeper, it's going to be fine to see where you got your eyes from. If your baby was born with blue eyes, but you or the wife or the husband does not have blue eyes, to kind of go back and see. And if your grandparents don't, but then go through your genes and say, oh, wait, my great-great-grandparents do have blue eyes, and that's how it was passed through. But why else would it be important? So here it says, tools used by genetic researchers or counselors to identify a blank. Talk over with your group and talk about why else do you think it would be important to have a Punnett Square in a family? I should hear communication. Why else do you think it would be important, not a Punnett Square, be important to have a pedigree in a family? Why else would a family want a pedigree or want to look at a pedigree besides looking at genetic traits? Hold on, talk with your group first. All right, Brandon, because Simon's not in your group. Okay, so tell me what you guys were discussing, because obviously you had a lot.
We were discussing how, like, everybody want to know about history about the family.
But, like, what type of history? Because blue eyes is history.
Like, who was in their family in the past? Like,
that's a family tree. We're in genetics. Brianna.
Would you say like a bloodline?
What do you mean?
Like, basically, like, different characteristics that a family might have that you can have. So,
What's a characteristic? Be more specific.
like a trait, like long hair.
Okay, that's blue eyes, long. That's eye color, hair color. That's all up in here. The relationship to figure that out. What else? Why else would it be important? India, Bestie.
Genetic diseases?
Genetic conditions. Good job. So therefore, you would want to know if there's a genetic condition that's throughout your bloodline so that you can determine, is there a possibility that if my husband and I have a child, is there a possibility that they could develop a genetic condition or have a genetic condition? Right? Would you want to know that?
yes.
Yeah. So what happens is when a woman is pregnant, the husband or the father of the child, or when the family comes together, the two parents of the child to be, they sit down with a geneticist, and the geneticist actually goes over some information, some history, family history, and he or she does a pedigree. Ask the father, is there any history of this? And I ask the mother, is there any history of this? And they go back as far as they can. So when I went with Tyler, they asked, is there any history of epilepsy or any history of cancer? And they mark it for what parent has it or what relative may have had it, so they can see if there's a possibility that it may be carried down to my child that I was pregnant with. But people also do a pedigree before they get pregnant with a child, so they can be precautious of that or decide if they want to have kids or if they want to adopt, especially when conditions run in the family. Does that make sense? Okay. So talk to your group and talk about why, again, you think having a pedigree is important so far. Why would it be important to you? Because in a couple of years, you all will be starting families. 5 to 10 years.
Because I don't know if my kids might carry the genes or they might have the genes.
Hey, Randy trying to have kids.
I ain't repeating.
All right, so now that we've talked that over, eyes on me, eyes back up here. Now that we looked at the fact that we're looking if there's a genetic condition, what do you think this information will aid in?
No, never mind.
What do you think this information will help with? Okay, prediction. A cure is not a prediction. A cure is after the fact, but the prediction would be called what? Starts with a D.
Diagnosis.
Diagnosis. Thank you. Because if a child is born with some defects or a child is born with some issues, then they can look back at the pedigree and say, oh, this may be a condition of this, because it does run in the family. The mom's father had it, or the mom is a carrier for this. Sickle cell is one. Pay attention up here. Guys, I need y'all to be 100% serious. Save the childish behavior for later. All right. So what else do you think it may aid in determining?
Who in the family is, I can't think of the words. So
Tila Nicer, help me. Not responsible. We don't want to blame and say, it's your fault this baby came out like this.
A carrier?
Not necessarily carrier.
Dominant.
No. Prone. Common. Another word starts with an R.
Oh.
Responsible.
Not responsible. At risk.
Oh, that's what
You said
Which is
something
the
with R.
risk.
Oh.
Which is prone. So prone for the genetic condition. So a child it may be possible that your child could come out with this. All right, so what I'm going to need, we're going to demonstrate, and we're going to use your knowledge of what you remembered some from Friday with this demonstration. But what I need two parents. I need a mama and a papa. Chappie is a mama, Hernandez the dad. So good. Back to where we started from. I need you guys to start right here.
Can I show my biggest? But she not having kids.
But she is in this one right here, so.
Shut up. Okay, I'm 41.
They're going to be considered the granddad A and grand. Oh, the names fell out.
You don't always have
They're going to be considered granddad A and grandma A. Okay. So, right. With that being said, remember we had specific symbols. Can their partners please jot these down for their notes? I'm going to need partner help. So whoever their partner was, I need you to help them out. All right. So with this information, we had certain symbols. What would the symbol be for Granddaddy Hernandez?
Square.
Square.
Do we need to write it?
Yes. So a square.
Can you get my notes? Neither one.
Simon, please complete her notes. A square represents a male. Now, Granddad Hernandez is married or fell in love with Mrs. or Ms. Hamilton, and now she is Grandma Hernandez. So the fact that they fell in love and they got married, what symbolizes marriage? A line that connects. So marriage. Who is he married to?
Marika. Don't call me Erica.
Which is a circle. So this is a female. Now how can we remember that? But what if you don't remember those labels?
Allegedly.
Oh, a circle stands for an egg which a female has.
Okay, you could say a circle stands for egg, which a female has.
Let's get to key blocks.
You could
What?
say off the record, chest, booby, whatever. Whatever comes.
Off the record.
All right. So anywho, this married couple, the male is married to the female. We have that, correct?
Yes.
Okay. Now, they have a child. Pick your children. Pick your child.
Right here.
You guys have a daughter.
Oh, right here.
Put your hands on. Okay. Drika here.
Wait, no.
Uh-oh.
No, we need to call. Where would you find
Here.
okay, your grandma.
Come on, we got time. All right, so I forgot to mention, guys, quiet. I forgot to mention that Grandpa Hernandez and Grandma Hernandez, they have a cup full of their genes, all right? So they have a child. Now, before we move on, Drika is their child. How do we represent Drika being their child? Draw a line down here.
Yeah.
And what?
Draw a circle.
A circle, why? Because she's a girl, she's a female, okay? Now, I'm not going to draw it really big because the symbols don't represent head size. So, this is the child. This represents, when you draw a line down or a bracket, if we needed to draw out a bracket, this represents the offspring. Okay? Any questions so far?
No.
No? Okay, very good.
No, but I need some genes.
Not yet. Alrighty, so Drika has to get some of the genes, but what you're going to do, you guys don't touch the genes, you're just going to close your eyes, you're going to pick 3 out of mom's cup and 3 out of dad's cup and put it in your cup.
3. Don't open your eyes.
Okay? Very good. So you guys just sit back for one moment because we have another family situation. I need another granddad and another couple. I need another lady and another male. Come on, Raji. Come on, Brandon. So now we have Mr. McGill and Miss Lowen.
How you doing?
I'm doing well. You guys stand over here, separate from one another. Are they turn to face them? Are they face them? Are they related to them?
Yes.
Hey,
Hey,
them.
cousins.
Stand next to each other. Drika, get over there.
Brothers and sisters.
Are they related?
No.
Does that say anything about them being related?
No.
No. Okay, very good. So therefore, what do I need to do?
Start another.
I start another one.
Another.
Okay, and another one. So Mr. McGill is represented as, guys, can you back up some so they can see? Oh, back up. You guys good? Okay. So okay, you know what, guys, go stand over there next to them, but you're not related, so no connection. All right, so I need to start them again. Mr. McGill would look like what? A square. Chest.
Yes.
Mr. McGill fell in love with the young lady and married her. She is now Mrs. McGill. How do I do that? A line and a circle. Thank you, Jadison. All right. They decide that it's time to have a child. They have a child and they have a budding baby boy. Pick your son. Drink him over. Drink him over. Pick your son. Okay, Ahmad, you are their son. So, how do I represent the fact that they had a child?
Bring that line down.
Line down.
And draw a square.
Draw a square. Okay. So this shows that this couple had a son, this couple had a young lady. So therefore, what you're going to do is you're going to close your eyes, take 3 genes from mom and 3 genes from dad and put them in your cup. Let's do that quickly. These families, you don't know each other. Stop talking.
Look what she just. This couple had a son and this couple had a drinker.
Yeah, that makes sense.
All
right, go. All right. So time goes on, and Drika meets Ahmad, and they fall in love and they get married. How do we represent that? First of all, Shauna, I need you taking care of Ahmad's. Who's taking care of Drika's? Okay, good. So what do we do? Bestie, how do we represent that they're married, Jalil? Where? Okay, so here, circle and a square. Now I'm going to put their names there just so that we don't miss it. So here we have who?
Aaron.
Aaron.
Put an
Little boy Aaron.
Here we have
Erica.
Erica. Here we have their daughter Drika. Over here we have Brandon. Here we have Roger Lynn.
And Ahmad.
And we have Ahmad. Okay, so these two are now married, right? Throughout their marriage, they are just loving life. They become rich, so they decide it's time to spread the wealth, and they have children.
6 kids.
So, it first starts off, they're eventually going to have 4 children. But we are going to first start off with the oldest child. The oldest child is a daughter.
Okay,
Come on, pick your daughter quickly.
Kylie.
Kylie, let's go. And Tasia, take care of her notes for me. How do we represent offspring?
Go another.
How do we represent offspring? Where? A line down the middle?
Put a circle.
A circle? Okay, but before I do that, they're going to have 4 children. So we need to represent that with a bracket. We don't just start pulling lines down from here. We're going to represent a bracket. All right? So that bracket is going to stem off just like a tree. And they had a little girl. What do I draw?
A circle.
A circle. Her name is Kylie.
No, her name is
Kylie, thank you. All right, Kylie, so what you're going to do, Kylie, is you're going to close your eyes and you're going to take 3 of your moms. Close your eyes and take 3 of your dads. I can have my grandmama and my granddaddy to go take your seat. Let's give them a round of applause. No, you died. You just are distant family. They move.
It ain't died. We retired.
Okay. Quiet. Quiet.
My family is not ugly.
Okay. Any questions so far? Huh?
No, we
No?
got
Okay.
this.
So far, they had, I'll wait. They had a daughter. And the daughter now has her genes. Now, Kylie, what I'm going to need you to do on this sheet, what happened to all my pencils?
You want them back?
I'm going to need you to take this and draw out the colored circles that you have in your chart. All right, Jigga, come over here now.
You want your pencils back?
Come on, no, I need you to be over here. We need to finish this. All right, so then they have another child, and they have a son. Who's the son?
Oh, we can't use our grant. Troy.
Troy? Troy just staying there, do nothing yet? All right, how do we represent a son?
A box.
A box. So what do I do?
Draw another line.
I need to draw another line
Draw another
from here. Because this is all, they're all related together. So this is Troy. Okay? Now, Kylie's just jotting down her genes. So she has them. She should have 6. Good. All right, Kylie, you need to dump take your genes and put them back in their prospective parents. So he should have oranges and the greens, and Drika should have the reds and the blacks. All right, Troy, you are going to now close your eyes and take 3 from the mom and 3 from the dad. Kylie, you can go sit down. Let's give Kylie a round of applause. Wait, come on. Then they have, Kylie, I need you to hold this though. Then they decide to have, Troy, I need you to take this, and I need you to draw out your colors that you have in your cup. They have another child, and they have another little girl. So what do I do? I need to continue this bracket. And they have a girl. What is she?
Circle.
Circle. Who's your daughter? Amat, choose your daughter. Shauna, come on.
Oh, come on, baby.
Oh, that? All right, so we have Shauna. Okay, pay attention, pay attention. Okay, take this paper with you, hold on to it. Put your jeans back into your parents. Hurry up, hurry up, hurry up.
What?
Now let's talk about this. Why are we putting the jeans back?
Wait, what do you mean back in Drew?
Why are we putting the jeans back into the parents?
Oh, because it's
Close your eyes though.
it's more components. I mean, it's a lot of
Yeah, because it's a lot of genes, so like you're putting them back because like the parents can't run out of genes, so like
Exactly. Because the parents give a child a gene doesn't mean they no longer have those genes anymore. They still have those genes, but it's all random throughout their children based on because of what? What's that thing we call when all the children have a random
variation.
genetic variation or genetic assortment? Very good. So that's one of the reasons why we're putting them back. I need you to jot down your colors on there. All right. Then they have another son. Remember, they had 4 children. So you guys have another son. Who's your son? How do we represent it while they're choosing?
A square.
A square.
No. We choose Vernon.
Vernon.
Oh,
Rihanna, where you? Oh.
We thought it was a Canard.
yeah.
Canard could be your son.
Okay.
All right. Vernon here. All right. Take it back with you. Good. All right, so Vernon now needs to take 3 genes from each. Are we taking care of our partner's papers?
Yes.
All right, very good. While we're doing that, we need to jot down a couple of things. First things first, we've already represented or identified what the squares and the circles mean. We've already identified the lines of marriage and the lines of offspring. The other thing that we do need to identify is other information that may not be pertinent on here, but we need to talk about how we actually enter information on a pedigree chart. So therefore, when we list the children for a pedigree, what order did we list them? Oldest to youngest. So we need to identify the fact that the children are listed from oldest to youngest. So now let's look at the bottom of your paper because it says on a pedigree. Did your color? Okay, you guys can go ahead. Come on, put your cups up here and take your seats. Okay, take your paper with you. Thank you so much. Let's give them a round of applause. All right, on the bottom of your papers, guys, on the bottom of your papers, you have a little key. You should be able to fill out 1, 2, 3, 4, the first 4 blanks about what each thing is. Go ahead and talk it over with your group or do it on your own, but do it now. Alrighty. So for the first one, it says a blank represents a male. What? Everybody. A square. For the second one, a blank represents a female. Circle. Very good. A blank straight. What kind of line? Horizontal. A straight horizontal line connecting the male and female represents a marriage. If they weren't married, because that does happen sometimes, it would be a dotted line. So instead, you don't need to, you could put this on the side if you like, but this would mean not married. All right. Now moving on, a blank connects the parents to their children.
Offspring vertical bracket.
A bracket. Thank you so much, Rihanna. A bracketed line connects the offspring to their parents.
A bracket.
A bracketed. Now, Kylie, what word, how many, well, actually, let me answer this. Out of the children from Drika and Ahmad, children, raise your hand again. Okay. Look at your, because you had jeans, and Ahmad's jeans were, what color, Ahmad? Orange and green, and Drika's were red and black. Out of the offspring, we are going to look at the gene green, the green gene. So let's say that represented green eyes, all right? So out of the children, which one of you had 2 greens? Or let me say, I'm sorry, which one of you had 3 greens?
No.
Which one of you had 2 greens? Okay, all right. So Kylie has the green eyes, okay? So to represent who has the trait, what we do is we shade it in. We shade it all the way in. So therefore, our next blank says,
Do we shade it in green?
no, just shade it, just color it in. So our next blank says, a circle or a square that is blank
Shaded.
means that person has the trait.
Shaded.
Shaded, fully shaded.
Fully shaded.
Which one of the children only had 1 green?
All 3 of them.
All 3 of them. All right, let's pretend that Vernon didn't have any of the green at all. Let's just pretend for a sake. All right, so Troy and Shauna had 1. That means that they are what? Carriers of the trait. So if you look at the other one going down below, it says a circle or square that is blank means the person is a carrier of the trait. Half shaded. It doesn't matter which side you have shade, but normally you see it on the right side.
We missed one. We skipped one.
Did we?
The one that says does not have.
We not. That's below this one.
No, it's not above it.
Oh, my bad. So we'll get back to that. My apologies. I make mistakes.
No.
So make sure you're looking at the one that says a square that is blank means the person is a carrier. These are carriers. If you want to note on here as well, you can put has, carrier, carrier. Vernon, I said, does not have the gene. So he is not shaded. So a circle or square that is not shaded means they do not have. Not have. If it were an instance, and don't write this, but if it were an instance, if you know the next one says that we'll discuss this later, but if it were an instance where you saw something that looked like this, and grow up. I know, grow up. Then this would be a dot. For the next one says, a circle that has a dot means the person is a carrier of a sex-linked trait. And we'll talk about sex-linked traits tomorrow. So if you want to put next to that line where it says a circle that has a dot means the person is a carrier, right next to that space, you can draw this to give you an idea. We don't have any here because these weren't sex-linked traits. These are just regular traits. Okay? Roger, you got a question?
Yeah. So Bernie doesn't have the trait, but since he's like, I guess that was me and Bernie's trait, and his kids have that, or no, since he's not a carrier.
He's not a carrier at all, so I mean he won't pass it unless his wife has it. He won't pass it at all. Very good. Yes.
Okay, so like, why do like twins like skip some generations? Is it just because?
That's another genetic thing as well. Nobody in my family has twins in my. Well, I'm sorry, not no one. My cousin was a twin, but her twin died at birth, and my aunt and uncle are twins. None of their children have twins. But my cousin, her son did have twins, but they both passed away. All right, so moving on. Now looking at our next one says, children are placed from oldest to youngest. And you can put left to right next to that so that you know we're listing them left to right, oldest to youngest. there is normally a key that is given to explain what the trait is. So over here, we'll draw a key. And green eyes. And the key is not only going to offer the fact that of what trait it is, it's going to also offer the information in regards to the trait. Yes?
Is this a real one or just an example?
This is an example. Now, the information that now we're just going to go back to,
Oh, we got the right in it?
we're going to go back to dark eyes, just for the sake of argument, because we know that dark eyes are dominant, okay?
Alright.
Dark color eyes. So a key is not only going to give you what the trait is, it's also going to give you the allele for it. So dark eyes are dominant. So therefore, what is the genotype for dark eyes?
D.
Is there more than one?
Yeah, dominant D, recessive. Dominant D, recessive.
Okay, so dominant D, or dominant D, recessive D. So the recessiveness would be, what would be the alleles?
Oh, recessive D, recessive D.
So light color would be recessive D, recessive D. So having that information, could we potentially go through and decide who has what? We could. We're not going to do it here. We're going to get an example. We're actually going to do it. But this is just the information to give you how a pedigree is formulated, the information that is included on the pedigree and what we look at. But we're not done, because we also need to list generations. Starting with whatever one we have first. Because we could possibly go all the way back. If you can go all the way back, that's great. But if you can't and you only have starting with the top one, that's going to be considered the what? What generation? First generation. And we list that with Roman numerals. The offspring of the first generation would be the second generation. The offspring of the second generation would be the third. If these children start to have children, that would be obviously the fourth, the fifth, and keep going as far as you can go from there. Any questions? Your project, Chappie, pay attention, is going to require you to list at least 2 generations with at least 6 family members. Preguntas about this?
Wait, how many generations?
2.
Oh.
All right, right now what I need you to do is talk over with your group about what you've learned thus far. Take about 1 minute to do that while I get it ready. All right, now if you flip your papers over to the back, it has some information for us to try, and then you're going to be breaking off to groups and you're going to be geneticists for other families. So let's take a look at the back. All right, so right here what we have is it says provide a key and correctly identify. I'll stop talking when you're ready. Provide a key and then correctly identify all genotypes of this family. You okay?
No.
Go get some water. The trait is cystic fibrosis, which is a recessive trait. What does that mean? Talk to your group for a second and talk about what does that mean for the trait to be a recessive trait. All right, Keelan's group. What does that mean to be a recessive trait? Keelan, I said your group.
The traits there, but less likely to occur.
Traits there, but less likely to occur. Not quite.
It means that Yeah, it means that the family carries the trait, but nobody has it because it's not dominant.
It's not gonna be as strong as much.
What it means is if it's a recessive trait, in order for someone to have it, they must be what? Recessive.
Thank you.
Huh?
In order for someone to have the trait, their alleles must be recessive.
How that
Blood
hit?
type O.
Like blood type O. Very good. Genes must be recessive.
I thought this recessive and you don't have it.
Some genes are a recessive trait, which means that if this is your gene type, that's what you have. Just like light eyes versus dark eyes. If you are recessive, then you have the light eyes, not the dark eyes. Very good. Understand? Okay. So then with that being said, is we still follow the same protocol. So for our key, this is for cystic fibrosis, which is a nerve, I wouldn't call it a disorder, but it's a disease, and diseases aren't always contagious, so it's a non-contagious disease where the nerves kind of overreact and it causes the person to be in severe pain for obviously no reason. They don't have to bump into anything, they don't have to hit anything, they don't have to be exercising. They're just sore, and you really can't treat nerve pain. All right, so cystic fibrosis, this is going to be represented, it is a recessive gene, so it's going to be represented with a what? We're going to use an F, but it's going to be represented with what type of F? Lowercase f. So, just like that?
No more.
So, what would the affected male look like? What kind of shaded what?
Square.
Square. So this would be an affected what?
Male.
Male. Drika, stop talking. What would an affected female look like?
Fully shaded circle.
What would a non-affected male look like?
A square,
Just a
not
regular
shaded.
square.
A non-affected female.
Regular circle.
Regular circle.
Non-shaded circle. Non-affected female. So now with your group, what I want you to do is I want you to go ahead and provide alleles for each of these symbols of male and female above or below the symbol. Take about 1 minute and to provide the alleles for the information that you have.
Brunette right there.
Yep, this right here.
So does that mean that the mom will be have a recessive?
I want you to talk it over with your group right now. All right, Simon. What was this dad? Recessive. What would this mom be?
Dominant and recessive test.
Why?
Because in order for those kids to be recessive, their mom had to have a recessive.
Okay, so did everybody hear that?
Yes.
Okay, so some people, Drika said that the mom has to be, 1 second, Roger. The mom has to be dominant recessive in order for her to have children. Is there a way for us to figure that out if your brain didn't see that automatically? A Punnett Square. But before we do that, let's identify what we do know. We know that these two alleles are going to be what? Recessive. Why? Because they have it, and it's a recessive trait. All right. So then we would have to do a Punnett Square to see if this mom is dominant, or if this mom can be dominant recessive. Correct? All right. Quatoria, stay with me.
Wait, what?
Let this be mom, and let this be dad. What's dad's allele? Recessive. We don't know mom's allele, but we know that 2 out of the 4 possibilities turned out what? Recessive. Some people can't see what the mom needs to be. Some people may not see that. So therefore, in order to produce recessive here, one of the mom alleles must be what? In order to produce recessive here, remember, India, you get one from mom and one from dad. This must be recessive. Correct?
Yes.
So therefore, the other allele has to be, why can't it be recessive? Because she doesn't have it. So therefore, the mom is a carrier. So the mom's allele must be,
Dominant F, recessive F.
what can these other 2 children be?
Both, same thing. Dominant F, recessive.
Why?
They can't both.
If we continue with our Punnett Square, they have to be a carrier because mom is a carrier, but not they don't have to be a carrier because mom is a carrier. They have to be a carrier because dad he has it, and he's recessive. So therefore, they're a carrier. Any questions about this, Brandon? No? No questions? Okay. So then, talk to your group really quickly and make sure everyone is clear on how we got these alleles for this couple, this pedigree. One second, because we need to cover this last part. You have a moment. All right, Brandon, everybody in your group good? You guys are responsible for each other. Everybody in your group good, Chappie? Chappie? Everybody in your group good, Raji? Everybody in your group over here good, Drika? She helping them out? Good. Keelan, I said, everybody in your group good? Yes? All right, Troy, everybody in your group good? Are you sure? All right. You said no?
Yeah, I got it.
Okay. All right. Now, let's look at genetic diseases. What's a genetic disease? Say it again, Brianna. A disease that's passed down from generation to generation. So it's something that comes through the bloodline, like Vernon mentioned earlier. So right now, we're going to correctly draw a pedigree and identify the genotypes of all family members based on the information that I'm going to give you, and what other conclusions can actually be made. So, with this being said, it has to start with parents. So how do we draw the parents again? What are the symbols?
The male is a square. The square is the dude.
Okay.
It's not too long for marriage.
So I'm going to draw it over here so everybody can see. All right? This family has 3 children. 2 sons, actually 3 sons. Draw it. They're not triplets. That's it's a way to connect them.
What did you say?
This couple has 3 children. 3 sons. I want you to check your work to make sure you have what I have. All right? The youngest son gets married.
What?
The youngest son gets married. Do it. Draw it.
No, he's on the right.
Who did you make the boy or girl?
We wouldn't do a pedigree if it was not a female because we're looking at generation and offspring. All right. Make sure you're checking your work that you have what I have. Don't wait for me to do it. This is testing your knowledge to make sure you do it. The youngest son has 3 daughters. Now, PKU is a genetic disorder that it allows, actually, without getting too much information with it, because you don't need that right now, but what happens is, how many of you has ever eaten something that is diet-free? Yes, diet-free. Or sugar-free, I'm sorry, not diet-free, sugar, or diet, like Diet Coke, sugar-free, okay? How many of you can actually taste the difference? A lot of sugar-free stuff includes something called aspartame. Aspartame is an artificial sugar. Some people can't taste that difference. Some people can. This here would represent the possibility of being able to taste that difference. But moving on from there, so here we have some information. Dominant P means unaffected. Recessive P means that it is affected. So in order, recessive P means that this is the actual trait, I should say. So therefore, let me give you some information about the family. I'll write it here. You don't need to write this, but then you complete your pedigree based on the information I give you. Generation 2, son. Generation 2, second son. Second oldest son has PKU. The wife of the youngest son in generation 2 has PKU. Generation 3, oldest daughter has PKU. Don't write that information down. Just complete your chart based on the information that I've just given you. Take about 30 seconds. Are the original parents affected?
No.
Do they have it? No, they don't have it. Does any of their children have it?
Yes.
Who? The second oldest son. So that would be this one?
No.
This one?
Yes.
Yes. Does anyone else in generation 2 have the gene?
Yes, the youngest son's wife.
The youngest son's wife.
No.
Right here.
Good. Look at your partner's paper. Make sure they already have this. We're testing our knowledge. Do not do it when I do it. Do any children of the second generation have the gene? Have the actual disease?
Yeah. No, the third generation children.
I said, does any children of the second generation have the disease?
Yes.
Yeah. Any children of the second generation?
The second
The second,
in the wife.
Wait, the first one.
the first, what is the first oldest what?
Oldest child.
What is that? Daughter, oldest daughter.
You said in the second.
Any children of the second generation is what I said. Any children of the second generation. This is a child of the second generation, isn't it? Belongs to that. All right. So now with that information, I want you to go ahead and start labeling some alleles. Talk it over with your group. Start labeling some alleles. Oh, Jenny's absent. All right. Quatoria, what can we label? We can label the shaded people what? Recessive P, just one? 2. So he has to be, make sure I'm drawing it so that it looks like a lowercase p, has to be recessive. she has to be recessive, and she has to be recessive. So far, based on the information we have, is this a dominant trait or a recessive trait?
Recessive.
Okay, so let's put that down. We do know this is a recessive trait, which means what?
Genes must be recessive.
Gene pair is recessive. Put to be positive, meaning to have it. Okay? Can we figure out anybody else?
Yes.
Yeah.
Who can we figure out, Jettison?
The youngest son of the second generation.
The youngest son of the second generation?
Yeah, that's very good.
How can we figure out that one?
Based off them and kids and wife.
Okay, so based off the kids, how did you figure it out?
Well, two of the kids have it. Well, I mean, don't have it, and one of the kids do have it.
Okay, so how can we figure out what the dad has to be?
I had put in Punnett Square.
Okay, in a Punnett Square. And some of you may see it automatically, but some of you may have to do a Punnett Square, and that's fine. This is mom. This is dad. So mom, we know, is recessive. We know one of the children is recessive. So therefore, well, let's put this here, actually.
He has to be dominant.
We know that one of them has to be recessive because the child got both. So this, therefore, would be dominant P. Does everyone see that?
Yes.
Everyone see how we got that? Kennard, get up. So, the other children, can any of them be recessive?
No.
No. Why?
Because
Because they don't have it. It showed you clearly there. So they would have to all be what? So notice we have this one here. That means that they had another child, there's a possibility that child could be. Doesn't necessarily mean that child will be, because remember the Punnett Square is the possibility of it. So therefore these children must be dominant, recessive. Yes.
Can I do the first?
Yes, for that, Drake, you had a question? All right, so who are you starting with, Chappie?
I was going to do the parents, so then we can find out.
You're going to do parents of second generation or first generation? First generation? All right, so she's starting here.
So, because one of their kids is recessive, I said that both the mom and dad, because they don't have it, will have to be dominant recessive.
They both would have to be dominant recessive. Jaleel, why? Jaleel, why do they both have to be dominant recessive?
Because the recessive is the second child.
Where do these little recessive P's come from? The parents. So they both have to have one. Remember, we get one from each. This is review from what we talked about. Okay, so this is this. Do these children have it?
No.
So they could be what? This one could be dominant P, recessive P, or dominant P.
Because it's one possibility.
It is a possibility, exactly. And if you didn't see that, you want to do a Punnett Square. What about?
Same thing.
He will be dominant P, recessive P because his kids have dominant P, recessive P.
And we already figured him out.
Yep.
So he has to be because of his children. Any questions with that?
No.
Yes.
You shaded it or
Good question, because we're not done. So therefore, is this pedigree complete?
No.
No, so we have to do what?
Shade halfway.
Who? Talk to me using generation. Talk to me using son or daughter or mother or father. Bessie, give me something.
I said
Second
second generation, the youngest son,
generation, youngest son,
passion,
half shaded, because he is a carrier. Good. Chappie,
First generation mom and dad have.
first generation mom and dad. Very good.
third generation,
Third generation, the rest of the offspring, or the Last two daughters.
First son of the second son?
We wouldn't do that because we don't know for sure. We don't know unless until he gets married and has children, then we can start picking that information up. So we don't know which one what possibility he actually got. Preguntas about this?
No.
Question. All right, now talk to your group really quickly and talk to them about why it would be important to know some information about this going forward with your children if this were your pedigree. What if this was a disease that could be helped? Why would it be important for you to know this pedigree about your family?
Is that like a medical if you don't have it? Or is it just things that
There's other things to it. I'm actually going to look up the exacts for it right now. Didn't remember off the top of my head.
Now can I go with you?
Oh, bro, just want to play.
Okay, so here's the information, and this will add more to your discussion. So PKU is actually a birth defect that causes an amino acid buildup. Where do we get amino acids from? Protein. So a strand of protein equals amino acid. All right. Where do we get our protein from? How do we make protein?
You said it backwards.
Y'all said it backwards. I just repeated what you said. So what was wrong with that, Raji?
You said a strand of protein makes amino acid, but it's a strand of
A strand of amino acids make a protein, so therefore let's back that up. Where do we get amino acids from?
Protein.
Protein. Really?
No, we
The strand of
we got from DNA replication.
DNA replication. What makes amino acid?
What makes
Oh,
DNA replication?
What? How many bases?
Four.
Three bases. Everybody say it with me. Three bases make an amino acid. Go.
Three bases.
Again.
Three bases.
And then a strand of amino acid makes a protein. All right. So PKU is amino acid called this phenolphthalein to build up in the body. It is chronic.
So that you know you can get treated for it.
So you can know why would this family, these two parents, before having children, why would this be important to them?
So, they can know the possibility of